All right, here we go. So now we're going to look at the 2014 question number 5. Particle x moves along the positive x-axis so that its position at time t greater than 0 is given by the function x of t equals 5t cubed minus 9t squared plus 7. Part A asks the question, is particle x moving toward the left or toward the right at time t equals 1, and give a reason for your answer. Well, what do we know? We know that x of t is 5t cubed minus 9t squared plus 7, and that this represents the position. So I can evaluate this function at any time that I want, and this will tell me where the particle is. It doesn't tell me the direction that I'm moving. For that, we need to look at velocity. Well, how do we get to velocity? Velocity is the derivative of the position function. So that means that the velocity is going to be 15t squared minus 18t plus the derivative of 7 is 0. I'm then going to evaluate the velocity at 1. 15 times 1 squared minus 18 times 1. Well, that's 15 minus 18, which is negative 3. What I know from this work is that the velocity at time 1 is negative, which means that the particle is moving to the left. Particle is moving to the left. Now be specific. When is the particle moving to the left? Particle's moving to the left at time t equals 1. That's it. In terms of how points were awarded, they said 1 point for considering the velocity at time 1. Now, I don't know exactly what they mean by considering. Does that mean that you found the velocity and then you plugged in 1, but maybe you made some mistake in the computations? Maybe. And then they say 1 point for answer with reason. It's these two things together that are like the answer with the reason. And so let's say that like finding the velocity at time 1 would earn you the first point for a grand total of 2 points. Okay, there we go. That's part A. Not too bad. A nice, friendly introduction to the problem. Let's see what happens next. All right, in part B, at what time t greater than or equal to 0 is particle x farthest to the left? Now this farthest to the left is going to be a really big idea. What do we know about particle x? We know that particle x is moving on the positive x-axis. The particle might sometimes be going to the right, it might sometimes be going to the left, and so I'm just going to indicate like this is what the particle might be doing. All right, particle is just going to go back and forth, back and forth, back and forth. What needs to happen for the particle to be farthest to the left is we need for the position, right? This guy right here, this is where you might say the particle is farthest to the left. The position of the particle, position is at the absolute minimum. We want the x-coordinate to be the smallest it can possibly be. Now maybe that's a small positive number, maybe that's a small negative number, I don't really know, but in order to do this we're going to have to find where the position is an absolute minimum. And this is going to be a lengthy process, but I think we're going to be okay. To figure out where the position has an absolute minimum, first we look for the candidate. The candidate is where your position has a relative minimum. Well, where does that happen? That's going to be when your velocity makes a change from negative to positive. You were going to the left, you stopped, you turn around, and you come back to the right. So that's our candidate. Well, we've already established earlier that the velocity is 15t squared minus 18t. We're going to set that equal to 0, And now we're going to figure out what value of t makes this true. I can factor out the 3t to leave me 5t minus 6. Solving this equation, 3t equals 0, or 5t minus 6 is equal to 0. This happens at t equals 0 and at t equals 6 over 5. Normally what I like to do is I'm going to make a number line now for my velocity function at time t equals 0, at time 6 over 5. We know at both of these places the velocity is equal to 0. What I need to do is I need to test the sign of my velocity at points before t equals 0, between t equals 0 and t equals 6 over 5, and after time t equals 6 over 5. So some convenient test points to the left of 0, how about t equals -1? Between 0 and 6 over 5, how about t equals 1? And to the right of 6 over 5, maybe t equals 2. You're going to evaluate your velocity at each of these times. You could plug into the original unfactored velocity expression. My preference is to use this guy here. At t equals -1, we get 3 times -1, that's -3. 5 times -1 is -5. Minus 6 is -11. If I multiply those together, I get a positive answer. At t equals 1, 3 times 1 is 3. 5 times 1 is 5, minus 6 is -1. We get -3. At time t equals 2, 3 times 2 is 6. 5 times 2 is 10, minus 6 is 4. 6 times 4 is positive 24. My number line looks like that. Positive, negative, positive. Now, it's important to note that in the original question they said, at what time t greater than or equal to 0? So I'm only going to consider values of t greater than or equal to 0. What does my particle do? I can see that the velocity is negative from 0 to 6 over 5. This means moving to the left. And then from t equals 6 over 5 on to forever, I'm moving to the right. And the particle never gets to turn back around. So starting at t equals 0, your particle moves to the left. At t equals 6 over 5, it turns and goes back to the right and goes to the right forever. So I'd want to say something like this. For t greater than or equal to 0, v of t changes sign only once. At t equals 6 over 5, v of t makes a change from negative to positive, which means that the absolute minimum position is at t equals 6 over 5. Sorry, that went off the page a little bit. The key is the fact that we know from our number line that the particle is going only to the left from 0 to 6 over 5, and then starts going to the right after t equals 6 over 5 and never turns back around. And although that information is contained in your number line test, you have to explain this in words. So for t is greater than or equal to 0, v of t changes sign only once. That's important. At t equals 6 over 5, your velocity changed from negative to positive. That would establish the fact that we have a relative minimum. But since there's only one sign change, that relative minimum actually becomes an absolute minimum. And so here's how they awarded the points. 1 point was awarded for considering the derivative being equal to 0. Great. 1 point for identifying t equals 6 over 5 is going to be important. And then 1 point is for your answer with reason. That's all of this writing over here, for a grand total of 3 points. I think B was really tricky. I know for my students, Some of them were able to find the derivative correctly, set that equal to 0, and solve. Very few students were able to do this next part. So picking up 2 points out of the 3, I'd say that's pretty good news. Now let's look at part C. Okay. Part C, this was a very tricky question. And I remember the first time I saw this question, I thought, what the heck is going on? A second particle y moves along the positive y-axis so that its position at time t is given by y of t equals 7t plus 3. Okay, hold on. We've been dealing with particle x that is allowed to move on the positive x-axis, meaning I'm going to move to the right or I'm going to move to the left. Now I've got particle y, which moves on the positive y-axis, and its position at time t is given by y of t equals 7t plus 3. At any time t greater than or equal to 0, the origin and the positions of particles x and y are the vertices of a triangle in the first quadrant. So we've got x that's allowed to move right and left. We've got y that is moving up and maybe it's moving down. And now they want us to consider the triangle formed by the origin, particle x wherever that happens to be, particle y wherever that happens to be. Well, I can see the triangle. Okay. And because the origin is one of the points, it's going to be a right triangle. At any time t greater than or equal to 0, the origin and the positions of particle x and y are the vertices of a triangle in the first quadrant. Okay. Find the rate of change of the area of the triangle at time t equals 1. All right, let's see if we can puzzle this out. The area is 1/2 base times height. Well, in this particular situation, the base of this triangle is determined by looking at the distance between the origin and wherever particle x is. That's what x of t represents. The height is the vertical distance between the origin and particle y. That's y of t. So my area is 1/2 x of t times y of t. Okay, all right, let's see what we can do here. What do we know? We know from earlier that x of t is 5t cubed minus 9t squared plus 7. Y of t, they just told us, is 7t plus 3. Okay. They want the rate of change of the area of the triangle at time t equals 1. So what we need is a prime of 1. Well, how do we do that? First of all, we find a prime of t. You always find the derivative of the function first, then you evaluate. This half is a constant, and so we've got a constant times this function, okay? 1/2 times this expression here. How are we going to find the derivative? You know it. Product rule. The product rule says take the derivative of the first function, 15t squared minus 18t, times the second function, plus the first function, 5t cubed minus 9t squared plus 7, times the derivative of the second function, which is 7. That's a prime. Now find a prime of 1. That's when we're going to evaluate at 1. Let's see, 15 times 1 squared is 15, minus 18 times 1 is 18. 7 times 1 is 7, plus 3 is 10, plus 5 times 1 cubed is 5, minus 9 times 1 squared is 9, plus 7 times 7. This is a safe stop. Everything is a numerical value. You don't have to simplify further for those of you that want to. Stay with me just another second. 15 minus 18 is negative 3 times 10. 5 minus 9 is negative 4, plus 7 is 3 times 7. Negative 3 times 10 is negative 30. 3 times 7 is 21. Negative 30 plus 21 is negative 9. We've got negative 9 over 2. This negative 9 over 2 represents the derivative of the area at 1, otherwise known as your rate of change. Now, how did they award points? They awarded 1 point for coming up with the area expression, 1/2 x of t times y of t. You maybe could have earned the point here. I'm not 100% sure, but I know for sure here. Then they awarded 2 points for correctly finding the derivative. That's when we use the product rule. And then 1 point for evaluating at time t equals 1. As soon as you plugged in 1 and you got all numerical values, that is called a safe stop right there. All the work that we did afterwards is just, you're running the risk of throwing away a point that you just earned. This is a really tough question, and it was worth 4 points. In my Calculus BC class this year, out of 10 students, I think I only had 2 or 3 students that earned any points on Part C. It was just so different from what we had done before. This is becoming a more common problem on the College Board, this idea of 2 particles now. So this is a great question. I'd want you to stop and think about this some more.